Recording in progress.
So, there's actually no one here, but I am going to go ahead and record a session anyway, since I said I would. So, let me share the screen. All right. Okay, so op amps. So what the point of op amps is, you take some input voltage and then you do something to it, and then you get an output voltage. And you have different op amps that, if you know the structure of them, then you can see what the output is going to be. Now, these op amps that I have on the screen right here are the ones from your PowerPoint. I think they're very clear and easy to read, so you can see what they are. One thing to be aware of is that, as far as I can tell, there's no convention as to whether the plus is on top or on bottom. So like if you look at the non-inverting amplifier, the VP is on top, and on the inverting amplifier, VP is on bottom. And you will see me refer to both VP for V positive or V plus for V positive, and same VN for V negative and V minus. I'll use both of those because I don't know, I just can't remember what I was using before. Now, in your PowerPoint, the A is standing for the gain, and what the gain is what you multiply the input voltage by to get the output voltage. And so for this follower, for example, this is just, the gain is 1. So the op amp, the V out, is the same as Vn, because the gain is 1, just multiplied by 1. If you look at, say, the inverting amplifier here, so inverting means that you're going to get negative, but be careful, you're not just getting the negative of Vn. It has to do with the resistors that are in your circuit as well. And so what you would get with the inverting amplifier is you get negative R2 over R1, and you multiply that by Vn, and that gets you your V out. And so these A's, the A is what you would multiply the Vn by to see what your V out is going to be. And then this one gives you the summing amplifier. This one is summing together 3 different things. But again, be careful, you're not just summing V1 plus V2 plus V3. Each one of these is going to be multiplied by something. And it'll be multiplied by, so V1 is going to be multiplied by R4 over R1. And notice that this is inverted. So it's a summing amplifier, but it is inverted because you get a negative. Now, you also want to be careful because the A is used differently in your book than in the PowerPoints. So in the book, the symbol for gain is G. So G is gain. And A is used for something different. I'll show you. A is used for something internal in the op amp. So A is this inside the op amp, which is what you would use if you were looking at a non-ideal op amp. So you have this equation for a non-ideal op amp. Now, last year, she told me that y'all would not have any non-ideal op amps on your test. So I'm not going to do the non-ideal op amp problems unless I find out differently. You should know, however, that your V out does need to be between minus VCC and plus VCC, and VCC is the voltage in to your op amp. Not your in voltage, not Vn, but it's what's powering your op amp, and that'll be VCC. Okay, so for your op amps, you have the 4 here. Now, I'll be honest, unless I'm currently studying these, I forget what they look like. And most of the problems you're going to do, you're not going to just say, oh, okay, well, that's a summing amplifier. Let me just plug in the formula. If you can, that's great. I mean, if you see it and you recognize it, that's great. I usually don't recognize them, and that's probably not going to be what you have on your test anyway. You will use them later in electronics, where it'll be useful to know what they are, or at least electronics too. But okay, so here are 4 of them, and then here they are as given in your book. So this first one is a non-inverting amp, and that's the same as this one, the top one up here. The formula is given a little bit differently, and it uses G instead of A, and then it's always listing V out as being G times the V source. So you have the non-inverting amplifier, you have the inverting amplifier that your output is going to be a negative of what your input is, but negative but times some constant in front. Now if you want it just to be exactly negative, then you make RS equal to RF, and if RF is equal to RS, then you would get, your gain would be -1. Here's an inverting summing amp. This is you have a subtracting amp right here. Notice that it is, even though on this output here it's showing a plus sign, it's subtracting because G1 is negative. You have the voltage follower, that's the same as the follower up here. And you have a non-inverting summing amp. So we had the summing amp, inverting summing amp right here, and the non-inverting summing amp right here. You also have, and I believe I got this from your notes, this one is a difference, so it's subtracting. And notice, so this one you're subtracting and you're multiplying the difference by R2 over R1. So if you just plain wanted to subtract, then you could make R2 equal to R1, and then you would have, it would just be subtracting them. Notice R1, you're using the same resistance for both V1 and V2 in this diagram. You also have an integrator, which wouldn't make sense until the chapter that you're on right now. It has a capacitor in it, and so if you integrate, the capacitor is on the feedback that goes from V out back to input of the op amp, and that gives you the integrator. And it looks like I had some font issues here. This would be a integral there. And you have a differentiator, and that would have the capacitor in between VN and your op amp. And so those are the different op amps that you might see. But again, I'm not going to do any practice where we just look at it and recognize it and say, oh, okay, well, that's, an inverting amplifier. We're going to look at using the rules for an ideal op amp. And in an ideal op amp, these are the rules, and this is what's important for, for an ideal op amp. IP equals IN equals 0. Okay, so the current going into the VP and VN, that's 0. So IP equals IN equals 0. That's important. The other one is that VP equals VN. That is also very important. And so by using these rules, you'll be able to figure out what your output is for your op amp. Now, these others, A equals infinity, Ri equals infinity, Ro equals 0, that has to do with the internal construction of the op amp. And so in your internal construction of the op amp, you have, if we had a non-ideal op amp, we would have this expression right here. And so when it says A equals infinity, that's not the A, that's the gain from your PowerPoint, that's this A inside here. And you would have a very high input resistance, and a very low output resistance. But again, I was told that you don't have to know about non-ideal op amps, and if I find out differently, I will go back and do those problems. So problems 1 and 2 on the worksheet were about non-ideal op amps, and it has, when you see open loop gain, that's about non-ideal op amps. So we are not going to do problems 1 and 2 right now.